It came out, I think, that it's first issue this year in MI's quarterly, or last issue last year, and it's a joint work between 4 scholars. And Aaron Lindbergh was the lead author in this. He's a PhD student of mine, currently at Stevens. Then the other one is also my former PhD student, Nick Parente, and then James Howison. All of these have worked on open source, and we wrote with Nick and Aaron another piece, which was published in 2018 in ISR, and this is in MI's quarterly. Actually, both of these originate from Aaron's thesis work, which was done around 2014-15. So you can see the time frame here. We are publishing it 10 years after, so it traveled a lot of different places before it got published. I think the basic idea remained the same, but the sort of technical execution and the sort of way in which we frame it has changed a lot over the years. And you will see what the final form is. Just get to the research problem, or what is the context in which this study emerged, and why we look at this novelty and complexity issues. If you look at traditional software and its design, such as which features to include, how to architect the components, typically these are guided by plans and methods, and these are enforced by hierarchical rules and policies. That's the traditional setting in which you build software in software teams, whether they're agile or waterfall or whatever. That's how it typically works. OSS communities lack traditional coordination mechanisms. They don't have really hierarchical rules nor policies, and nor do they follow any plans or methodologies, which are the key forms in which you coordinate activity, which determines the features and the architecture and many other things. Typically, there's an assigned role like software architect, which makes decisions on the architecture and so on. So this begs the question, how do OS communities coordinate their software development, decide and evolve system-level software features? That was the broad, large question which we started with. And we feel that this hasn't been really addressed. There's a lot of work, of course, in open source on all types of things like incentives, how the networks influence possibly the way in which people coordinate, or what type of features become accepted and so forth. But this sort of more holistic assessment of the sort of how the community as a whole shapes the output and the features of the software as a whole hasn't been really addressed very much. And there's some work which have looked at some elements of this coordination problem, because it's a hierarchical problem, basically. So there's a lot of work which have looked at dependencies between specific software components, especially within those software components. This is the work by Howison and Crowston. That's why Howison got into the paper, which is the well-known work on modularity and superpositioning. This is interesting work, but it basically assumes that you have fixed already the architecture. You know the modules. And then after that, you basically lay over code over these modules, and you add possibly new modules. But you don't really change the architecture, and you just add features based on the modules which you have, or adding new modules. But it is more like an additive linear evolution. And then we did another piece, which was in 2018, actually, not 16, paper, which was in ISR. We point out that those who know anything about software, they saw that not all dependencies can be captured by modular interfaces. There are always other dependencies between different parts of the modules which are not coordinated by the interfaces. And there are also certain type of knowledge which needs to be shared between different developers of the modules in order to really build the software together. That's well known from software engineering. It's in certain aspects, certain features have been known, like reflected in things like aspect-oriented softwaring. For example, security issues need to be coordinated across all the different software components. So, and then we asked that how do these types of dependencies, how are these addressed? And we basically pointed out that there's over time, these communities build certain types of routines. It's like self-organizing routines through which these types of issues are sorted out. And we showed in this paper that that if you develop those routines, you were much more likely to actually get tickets accepted versus those which didn't have these types of routines, if you look at the sort of development processes in certain communities. But then it still begs the question that what about the emergent holistic features, software, including many of the non-functional features like flexibility, scalability, and so forth. These cannot be coordinated in either of these mechanisms. So how are they done? And are there differences between how different communities address those? And that was the sort of issue which we are looking at this paper. And we look at two emergent software features which are always present in software development. One of them is novelty, which means that typically in the next release of the software or a new package, software product or whatever, it is expected to have some original distinct features and functions which separated from the rest. And if you don't introduce this novelty and you have less novelty than others, typically what happens is that the usefulness or the ease of use of the software deteriorates due to the weak compatibility with the existing evolving standards or some other components. So there's this ecological aspect of that. And the other one is that generally, if you don't introduce novelty, it will limit over time software features, and it doesn't make the software competitive in the marketplace, and its use will decline. So pursuit of novelty is pretty much necessary even for most open source communities if they want to remain viable over sort of longer period of time. But it comes with a certain cost or a challenge, which is that if you introduce novelty over time, you have to at the same time face the issue that the software becomes more complex. It has more features, more types of dependencies to coordinate and so forth. So you increase the volume and the variety of components, and you also increase the relationships, the dependencies between those components. So the software grows more complex. And this has been known in software engineering since Manny Lehman's sort of groundbreaking work in the 80s. He studied large IBM operating systems and their growth. And then we know from the increased complexity that it results in escalating maintenance costs. It typically, over time, results in technical debt because you start cutting corners, to address complexity issues. And it imposes steeper learning costs for developers and also the users over time. I had a paper recently in Transactions of Software Engineering with Michel Benarok, where we showed actually that the maintenance costs, if the software is more complex, is not linearly more higher. It is curvilinear. It's a quadratic function. So if you have a double this complex software in terms of certain measures, you get 4 times more maintenance costs. So it is a really significant impact on the complexity of the software. So both of these need to be addressed. And as you can see, originally we said that there's technical debt and they're totally at opposition, but they're not. But they are interacting in a relatively complicated way. And if you pursue one, you have to address the other in some ways. And there's also ways to address the complexity, for example, refactoring and so forth, but they imply costs and additional effort and also risks. So there are choices of levels of novelty and complexity which any software development community has to do, and these are critical for the software evolution and adaptability, especially for what Manny Lehman called E-type software, which are the software, when you put them into the environment, they change the behavior of that environment. So there's feedback loop back to the software itself. It needs to evolve based on the learning in the environment. If you have a software which computes SYN functions, for example, SYN functions are mathematical, there's no such relationships. But most software is like E type of software. When you put them in the environment, they generate response from that environment, which leads to additional evolution in the software. So you need to balance somehow this relationship between the novelty and complexity when you develop the software. If you look at that at the level of OS communities, they have to choose certain levels of novelty and complexity. And by doing that, it also signals that the types of participants it seeks to attract. There's some research on that by Kalle and so forth, because people want to be associated with good designs, for example, which are novelty, cool things, so to speak. But at the same time, this type of thing requires system-level community-wide coordination, which extends over the project lifecycle. So it's not only for one release, it's across the releases. And it affects how the community attracts and keeps participants and how it shapes their activities. And currently, we know little about how OSS communities shape the whole software artifact along critical dimensions, like novelty and complexity, as reflected in their design. And we say that these are typically reflected not in the methods or in hierarchies, but we introduced this idea that there are certain design principles, there are certain normative expectations, which community within the community people share, and also examples of those. That what is good software and what is a good way of developing and writing software. And the other one is core doctrines. What a good software would look like, how it's composed, how it's expressed, and how it is actually, and based on that you can evaluate. And of course, those who are guardians for the software, gatekeepers, like those who are the maintainers and so forth, they typically embody and enact both of these, the principles and the doctrines, because there are certain gateway functions in the software. So the principles, how to go about addressing software development problems, and doctrines, what counts as a good software design, and how you can make sense of it, typically guide in communities how these software artifacts are shaped and how development should proceed, are expected to proceed. And also examples of both of these. These are really important notions sort of to address that. Now, how do you actually then shape those doctrines? They don't come out of thin air. These are community products. So how do they emerge? And we posit that they actually emerge through talk. People talk about when they write software and before they start writing the software and when they evaluate the software, they talk. And they build certain type of discourse, and that discourse plays a critical role in sustaining these cognitive and normative expectations and establishing the standards around principles and doctrines. What is the content of that and what they should include? And those doctrines and principles allow them to have a certain common understanding or common ground, as people call it, and also coordinate how they tackle thorny problems such as technology roadmaps, architecture, and technical debt issues. Now, the question is that how does such discourse shape and what is the form in which this discourse evolves? So how does this actually happen? Or how does this discourse sort of shape these doctrines and principles? And that was the key question. So we asked basically, how do these OS communities sort of engage in a discourse to shape the novelty and complexity of the software they develop by enacting certain types of doctrines and principles. And right. Now, one aspect of that is that which relates to the doctrines or principles is that sort of how do you think about both of these aspects of novelty and complexity? And we said that basically there are two ways, and that based on, and also with the evidence. And we had originally 4 communities which we look at. We had a very rich interview data set, and we look at how they talk about new versions, how they evaluated novelty or new aspects in the software. And we found out that there were 2 basic principles. Some emphasized proximal novelty, which was largely that whatever you had currently, you sort of expanded it, you refined it, you moved a little bit further. It was like incremental expansion of the capabilities. So you were searching novelty near the current state of the artifact, so to speak. And then there are situations where some people, either within the community or outside the community, they learned something and crafted something which said that this is cool. And they said they searched novelty which was conceptually distant from the current state of the artifact. And you could see both strategies being applied. Then the other one was how they approach complexity. And one of them was the idea that they will handle the complexity in a way that they reorganize the software, but in order to reduce the complexity. And they try to maintain the software as in its current state and reconcile interdependencies as the software grows. So it was largely driven by the fact that they wanted to maintain backwards compatibility, so that they wouldn't lose any users or impose additional strain or effort to the users if you sort of moved out, if their way of using the software was not anymore compatible with the new version. But then we said other situations where there was a depreciation, where basically some software communities said that we are going to retire old code and certain features or certain APIs to make room for new features. We cut features, we prune them as we move along. And that's one way of addressing the complexity. And now, how does this relate to the discursive this ideal modulation? So, as I pointed out, OS's community members establish these principles and doctrines through talk. They don't formally write them down. They might be occasionally written in certain types of documents which are available, how we think about the software. And I'm going to provide some examples of that. But typically, it's in the ongoing talk about when they develop and talk about the code and related artifacts. So we draw this idea that basically pilfered a principle, what Arthur calls principle transfer, which is that the transfer of the principle of one scientific field to another to make sense of this idea. So we draw on signal processing and audio synthesis and their concepts of modulation. How an existing signal is modified to produce sounds with particular characteristics when there is no control of the signal at its source. That's the idea of modulation. And you can say that this has a relatively nice match, metaphorical match with the open source software, because in the open source, the modulation takes place through community discourse, which modulates and shapes principles and doctrines and affects how code acquires specific shape and organization. And the reason why it is applicable is that there's no hierarchical control. So even the people in the core, they cannot really dictate what the people in the development space can do or what they can say. They cannot really do that. That's autonomous. They cannot control the source, so to speak. They can only try to influence the way in which types of things from the multiple sources becomes synthesized into a certain type of view of what the good software is or is not, and how you would go about developing it. So you can think that this in a way that developers autonomously develop code. That's the sort of basic idea of the bazaar. Anybody can come there, they can write code, and there's of course developers who can look at that code like million eyeballs and so forth. Then there's this discourse, which sort of modulates through the talk, how you talk about the way in which this code is being developed. That's the idea. And the modulation influences largely what type of code becomes selected by establishing the principles through which you evaluate which types of code is viewed as worthy of being included and why. And we saw that there are two types of mechanisms which the modulation does, which are mixing and filtering. And I'm going to talk about those two. And also examples of those. First of all, there's one type which we call filtering, which is that you encourage or discourage certain discursive positions, certain ways of talking about the software. You say that this doctrine or this type of way of organizing module is not good. It needs to be done in this way. That would be one way of saying that. And there may be, of course, who encourages? It might be that the community has established itself already a precedent as a doctrine, or there are some people who have power or reputation to make that. Like if you are in Linux community, if Linus Torvalds in his pretty rude way comes and talks about certain things, people listen and they will take note of it. And that influences the way in which people will write the code. Another one is that occasionally there are multiple viewpoints and you have to interrelate those types of positions as to forge decisions. What actually, because there may be conflict, you have to have some way of using that. And typically you use certain principles and certain types of ways shaping and which shapes the doctrine, how you actually go about integrating mixing certain positions and certain arguments in favor of certain type of doctrine or principle. Over time, we can say that the discursive modulation evolves the software towards certain characteristics which are consistent with the nature, sort of unique nature of the community. Each one of them is a little bit different. It shared goals and values and what it views as good design, which is embodied in these principles and doctrine which it enacts. And the outcome of the synthesis is the timbre, which is the unique characteristics of the sound produced. In this case, it is the software artifact, what it looks like. And of course, the timbre also captures then that software also captures the idea to what extent it manifests the novelty or complexity. And we can say that this type of how you sort of establish positions through the discourse and establish and prefer certain positions in the discourse is the key way in which the software communities at the community level shape novelty and complexity. They build a shared common understanding of that over time as they move along in building and writing the software. And just to point out that this is the case, of course, the way in which the whole study, this front end was not there. It was built based on the case. And we have two cases which we looked very different, and we purposefully sampled very different in terms of the way in which they developed the software. Especially how it was like sampling on dependent variable, if you want it that way, criterion. These are very different in terms of how they manage complexity and novelty. And then based on that, we then looked at how they organized their discourse, and how they modulated that discourse, how they built the doctrines and the principles. And in many ways, these are similar. Both of these are web development framework, which is one of the most popular and largest type of software which you can find in open source. Most of these are housed in GitHub, and you can get data about them through GitHub. Django, which is Python-based, Python offspring community, and it's originally housed and developed mainly by European developers. And I'm going to provide much more detailed account of the Django just for the sake of the time. Then the other community is Rails, which is founded on the programming language Ruby. It's also very widely popular and quite common. The originator of this community actually comes from Japan. And it's in a very different way in which it's organized itself. They are relatively similar in terms of size, complexity, and so forth. I'm going to show some examples of that. So there are some similarities. They are hosted on the same GitHub support platform. So the platform, how they develop the software, doesn't really distinguish these. The way in which they can organize their discourse is very similar. They are both relatively successful. Both are well-known and enjoy a reasonable degree of success. There's some evidence of that. And they are among the most popular full-stack web development frameworks, and in different programming languages. They have built substantive and sustainable communities. They are, I think Python is larger, but both of them are quite large. And they are medium-sized. They are not the monsters like the Linux or Apache, but they are still significant. And they have been around now nearly 20 years, many of them. So they have had multiple official releases and had time to establish their epistemic foundations, which means the doctrines and the principles. These are the numbers you can see. The core team members are very similar. So they appear to be organized in a very similar manner. And you could call that they constitute typical cases of medium-sized OSS software projects, large enough to have a substantial community, but small enough to be governed by emergent community-led dynamics that involve significant discursive practices. All right. The difference is largely that they fall apart in their approaches to software and how they organize the discourse, as I will show, and how they modulate it. that sort of discourse, how they approach the novelty and complexity at the sort of overall artifact level. So here's just a method. I'm not going to go through, but it shows that this was a mixed method study, although I would say that the qualitative part was the dominant one. So it's a small quant, big qual. And the quantitative part basically was downloading all the 14 code bases structured in file folders and so forth. And then we computed metrics for complexity and also certain metrics to compute the novelty. So we could show that they're different. So we have the baseline to say that they're different. And we also visualized the evolution of these various metrics over time in order to say that, that they evolved in a certain manner. But the key point of the study was the conducting interviews. We conducted interviews with Skype and face-to-face conferences, 25 interviews overall, so about 12 to 13 between each of these communities. And at that time, these were done in 14, 15, 16. It was easier to get actually access to these people. These were the core members of the team. There were also some which were in the periphery. So we covered both. And then we did the open coding, which resulted in this idea, which I pointed out, that emerged from the coding and related theoretical triangulation. But we also validated that by collecting archival data, newsletters, email threads, and we also sampled those and also triangulated the interviews with those. So it covered both the interview data and other types of data. And we had a relatively large number of codes and other things. And based on that, then we did the final theorizing. So it's first coding and then the final theorizing, which was to conduct the theoretical sorting diagramming, which I will show, and some other things. And the emergent theory was this idea that the modulation is the driving mechanisms through which you shape establish the foundations through which you talk, and the talk shapes the way in which you evaluate the code, and the code gets a certain type of outcome. And it's a sort of self-reinforcing feedback cycle in these systems. Now, I'm going to look at, use these constructs to look at one case. I don't want to use both, but you get how the analysis was done. So and I'm going to pick up Django. Django, as I pointed out, is a software community which originates from Python. And in this community, generally has the image that they are an engineering community. Stringent, sort of, if you know anything about Dutch or German type of software engineering, that's their image. So filtering in this type of environments happens through appeals to explicit and unitary coding conventions. So they said that if we have a certain type of computing problem, there's one best solution for it. And you strive for this type of unitary explicitness. Whereas the mixing happened through structured dialogue, which meant that they were relatively democratic, and they would actually always see that we can come together into a table and talk and figure out and find the best solution and come to a consensus of this. So the modulation, as a result, nearly always strives towards a consensus around the singular solutions. That's the idea of the unitary explicit and seeking consensus. And given the fact that there are a lot of members in the community, especially in the core, who have invested their careers and their knowledge into this community, it's very likely that they like the stuff which they have already. It's like the academics, very similar. So integration typically happens through consensus because it happens through consensus, limits the distance of a new version from the current version. So they typically evolve the software through proximal novelty. So it's sort of like a slowly moving sort of a train which adds all the time new cars and new features into it, but it's the same train. And given this thing, it also they had to also integrate multiple positions, which enacts an approach to manage complexity, which tries to cater the needs of the whole community. They emphasize integration as a form of managing complexity. So here are some examples. So the development was founded on rigorous, and they called themselves serious engineers. This is a direct quote what they said. And they said that there's a single best way of solving technical problems. We have one example, for example, a co-developer disagreed with the particular proposal because it allowed multiple ways of achieving a single programming goals. And then he said there should only be only one way, best way to do it. And then other ones said, I agree with that. These overlays complete the cycle or divised by, and this is the technical thing, only way to it. And the explicit also implied that they wanted to have at all times a direct control of all code parameters and also display informative output. So the code need to be very explicit. What it was doing, there could not be any implicit assumptions about. When you read the code, you had to not had to assume anything. Everything should be written down clearly. And it eschews automating functionality behind the scenes and give a better control of what the code does. And if you go to their site, this is the doctrine. There's this type of well-known memo, which is called the Zen of Python. Which is a set of aphorisms describing how to write Python code, and therefore Django code needs to follow that, and that decides how it ideally should be written. And if you look at the mixing part, it was organized around this structured dialogue. So it relied on processes of principles comprising of a formal specification, documented the solution, and by referencing common heuristics. Again, this idea that you're very explicit of what you're doing, and you have to write it down and share it. And to pass the scrutiny of the community, the proposal had to be demonstrated to be in line with accepted and shared quality criteria. So there was a doctrine immediately applied to it. And of course, it is interrelates and discursive positions. People might still have different opinions about it through structured dialogues. But the dialogue itself was respectful, non-competitive, and reflected amicable relationships. It was like philosophers sitting around the table. They may disagree, but they strive for the best solution. And the mixing was carefully orchestrated by expressions of willingness to work hard to form consensus that was signaled as an expectation by complying with shared technical standards. Here's one developer how it characterizes. So decision-making Django goes by rough consensus and working code. So it's very similar to if those who know internet, IETF doctrine. The process that started is the right way to work constructively on rough consensus. But people who really want this feature need to play their part in coming up with the working code, and code needs to be well tested to be considered as working. So there was a clear articulation what had to be done in order to be worthy of even starting to enter into this type of dialogue. And if you look at it as a whole, when these principles were applied, they typically created a singular solution through consensus, which entailed that they would produce proximal novelty, and they would follow an integration approach to manage complexity. And they focused on maintaining stability of the software while refining existing features. That's another way of putting it. And they viewed themselves as stewards of a complex yet coherent system. This is a very good expression. We take pride that we are boring, slightly predictable framework. If you want something stable and reliable, then Django is a decent choice these days. The community seems to be more focused on stability issues versus banging out brand new things and all of this new stuff. Now, Rails is nearly the opposite. I'm not going to go through that, but I just point key points of it. The filtering focused on emphasizing ease of use and expressiveness. So whatever the different contributions made, if it made use of Rails generally easier, that would be a thing which they would consider. The other one is that they used the metaphor that writing code is like writing poetry. That was one of the quotes. And they said that if somebody would be really in a cool way expressive, that would be valued. It's nearly the opposite from them. So the more different ways, but if they are smart ways, those would be preferred. And they would tolerate non-explicit code. It promoted developer happiness and flexibility. in how the end user can code and write the Rails apps. And they emphasize the need to be more expressive, able to readily develop any features that express their priorities with relatively few lines of code. So the sort of economy of expression was emphasized. And the filtering resulted in unstructured contestation. Typically, there were multiple different viewpoints. What is expressive? And these were unstructured, so it led to contestation between different viewpoints within the community. And the arguments, what is actually ease of use and what facilitates ease of use? And typically, the way in which this was solved was by authority. The leader of the leaders of the group said that this one is good, one this is not good. So there was no dialogue. There was no strive for consensus. It was, and by picking up certain types of forms of expression, you of course establish precedents through which people could evaluate what other types of expression contributions might be worthy of expression. So there was a certain way in which the doctrine was established. But the principle was not through any type of rational argument. It was just by somebody expressing based on reputation that this is the way we are going to do it. So this type of contestation led to the fact that there was a lack of explicit process of resolution, and it always became very personal and contentious. They were fighting with one another, many times in an emotional level. Of course, this invited little integration of divergent discursive positions. So they mainly encouraged digital novelty, and they also followed depreciative approach. So they just pruned out features if they thought that they were not anymore cool or they were not anymore needed by the view as viewed by the community, despite the fact that some people who were using the system might actually suffer from that. So it very, as I shall point out, these are very different. So this is like an overall summary of that. You can say that the explicitness, especially in the Rails, it's also inheritance from the Ruby. Ruby community is very similar. And the goal was the program happiness, ease of use. And they emphasize convention over the systematic configuration of the software. And they were tolerant of magic behind the scenes, but making the work of the programmers easier. And they valued multiple ways of accomplishing specific tasks. It's like writing poetry. You can write the same different types of love poems, but they're all love poems. And it produced diversity in discursive position just because of the way in which filtering was carried out. So how did they mix those views? It led to this type of unstructured contestation. So they used personal experiences of use cases as basis for discursive positions, not common views. They were contentious and lacked a commonly understood and accepted process. So every acceptance or every ticket basically was sorted out a little bit different. They didn't have any systematic way of doing it. And discursive positions of influential developers who were in the core typically won the case. And they wanted to be in the cutting edge, which is the digital novelty, and they valued progress over conservatism. And they were skeptical of complexity. They didn't like it because it went against their idea of ease of expression and other things. So they were ready to break backwards compatibility, and they depreciated these obsolete features and technologies. So just to point out, you can see here that novelty per file. You can see that Rails is actually much higher constantly over these releases. Complexity per file, Django is complex because they try to integrate backwards. It makes them more dependency, they have to manage that. And that this was per file, so per module. And this is the total novelty calculated across all overall software package. So this shows that these practices produce constantly different choices which are manifested in this output.
Thank you, Kalle. A super interesting presentation. I really like how you try to seek out what replaces hierarchy in these open software systems. I'm just wondering, so what I get from your story up to now is the things that replace hierarchy in open software systems are either technical principles or influential developers.
Yeah.
So it's not exactly hierarchy, but there is something that people listen to. And I just wondered, like, how do these emerge? Like,
I'm going to
who
get to that.
determines who is the influential developer? Who determines what is the guiding technical principle in these systems?
That's a very good question. And we didn't study that, but I raised some issues about it. And there are some ways of sort of thinking about it. And I'll come to that at the end. I think you're at the spot, and there's also there's not just one factor. So it is an outcome of both sort of the how the discourse or the talk produces certain ways in which you share a common understanding within the community. What is the sort of good way of developing a software? You agree on those principles like dialogue versus something else, or you establish certain principles what counts as a good software itself, and these need to be established. But how you come to that is another thing, and then it might be created by inheritance or tradition. Like as I showed in both cases, they appear to inherit something from their father communities, which were typically the programming language communities. So there's a certain way of transfer of these principles. But there also another aspect, which is persons matter, I think, in this case, because these are not hierarchical organizations as such, but the powerful persons in certain situations matter. Yes, Ping, good to see you.
Yeah, hi, colleague. Nice to see you. Could you remind us how did you measure this on this slide? How did you measure novelty and complexity?
For complexity,
yeah.
For complexity, we use the normal object-oriented complexity metrics. So because these are both object-oriented languages, and there are metrics for how complex is each object.
How about novelty?
Yeah, a novelty we calculated by the how much it differed from the other parts of the software. And then we also matched it with the total complexity with the release notes.
Okay.
Thank you.
Thank you.
Yes, the reviewers were always hesitant about this. It's not easy to establish, and we are not really, even software community is not very good at how you measure, especially software novelty, because novelty is largely it's very difficult to determine just by looking at the code. It's more like a relationship between what the code does in relation to other code and what it does in relation to a certain user group. There's something new type of behavior which it enables. And the latter one is largely captured by, of course, the release notes, because the release notes communicate typically that how it's different from what has been and what is new in this feature. And typically, I had another PhD student who also did another study on this type of thing just recently. And if you look at open source communities, how they organize that, typically the novel features are the first ones which are written by the maintainers when they release the next node. And we did some interviews also, and they said that, yes, that's the principle how they follow. They write those onto the top, which they think are the most novel aspects of the new release. Well, hopefully this sort of clarifies. Right. So this is what we learned from these case studies, these two case studies, and as I said, these should be interpreted as theoretically sampled typical cases of certain types of communities. But we can sort of engage in certain type of things which they manifest, and you can say that because we have sampled pretty much across the sort of spectrum, they express different types of archetypes. Archetype, I mean that there's a certain configuration of how the filtering mixing interacts with the novelty and complexity, and we call them tuning and expression. So if you think that this is the modulation, the tuning basically tries to sort of tune in a best possible way to get a certain type of outcome, which is very similar over time. Then you emphasize unitary explicitness, this structured dialogue. You pursue proximal novelty, and you seek to integrate to be backwards compatible. That seems to be one way of sort of evolving software. But the other one, which is expression, which is largely the idea that you want to modulate in a way that the next expression is different. Then you will facilitate the expressiveness and ease of use in filtering, emphasize those features, but mixing is unstructured condensation. So it's largely the jungle or some sort of, there's no due diligence how you actually come up with the best way. It's somewhat random. It's not totally random, but there's certain randomness in how this happened. Improvisation is another word which you could use. The novelty which comes out of that is typically distal, and complexity, because you just by doing that you increase the complexity, as I saw from the average complexity. You need to manage it somehow, so you have to largely probably depreciate over time. And this is how this worked at the Django. So if you look at the discourse itself, the structure, unitary the explicitness produces a set of common ground discursive positions. So these are more similar to one another, which enables structured dialogue because we have a common ground. And then that again produces compromises through discursive positions. So it sort of sustains itself, a certain form of discourse, through which certain types of positions in doctrine and principles emerge. And then as a result of that, you get the artifact which has proximal novelty, which it suggests that you integrate with the existing code. So you sort of layer things, add on the code, which leads to the fact that you have to somehow integrate the complexity with that. And because you want to do it proximally, you keep all the existing users and you want to keep them, you have to reconcile interdependencies and integrate. So these seem to be like two self-fulfilling, a certain type of fulfilling cycles, which reinforce one another at the level of the artifact and at the level of discourse. So these are mutually dependent from one another. Similarly, you can say that in Rails, because you have facilitate ease of use and explicitness, so you produce diverse discursive positions. That's expected. So which leads to unstructured contestation. You cannot mix them anymore easily because people cannot agree on the basic principles. So which produces winning discursive. So somebody has to pick it up. And it becomes somewhat more random process. And that results in the fact that you have much more highly likely that you will produce distal novelty. But distal novelty adds complexity into the system, much more than other ones. And you have to clean up the lacking features in order to manage the complexity, which leads to the fact that you have to depreciate the complexity, which makes room for additional forms of distal novelty. Again, these are like self-reinforcing types of mechanisms in both cases. And based on that, we sort of built this more generic idea that the filtering basically selects discursive positions, which can then be mixed. Depending on the diversity and variety, you produce, again, specific combinations of discursive positions. And this is like a self-reinforcing mechanisms in discourse, which defines how the doctrines and principles are built up. And that mutually shapes then the novelty, which creates interdependencies, and you have to address the complexity, and you have to add it somehow, which constrains or enables new feature development. So again, this is like these are mutually dependent interactions. The discourse reflects the artifact, and the artifact shapes and reflects the and the discourse shapes and also makes sense or provides lens to understand what is a good artifact. So they move together. All right. So if I put it to the overall, so what are the contributions? I'm sorry that I went a little bit over time, but I'm finishing now. So the discourse and the artifacts, they all relate to each other through this mutual shaping, as I pointed out. That's probably the important aspect at the level of the overall community. And it advances understanding how the community shape holistically the software artifact as a whole, in the absence of traditional governance mechanisms. And the OSS communities can promote various discourses which modulate how the software artifact gets shaped, and they can foster certain chosen foregrounded outcomes, principles and doctrines, and exclude others. And that they need to do that. They cannot maintain that everything is possible. There is a certain way in which they have to make choices. I'm going to get to that. That was raised. How do they come to those? So one aspect which we can point out is that OS communities are not chaotic and anonymous bazaars. When you look at this quote, they are rather consistent spaces of what types of knowledge is valued and matters and how it is mobilized and legitimized in shaping software. And those community discourses are the mechanisms through which this happens. And contestation is crucial for digital novelty. You will have more fights if you want to have novelty. That's one way of putting that. But it imposes cost to users through depreciation. The other option is that you will have less contestation, but you will have proximal novelty. But then you have to address this other issue that if you want to keep everything happy, you add complexity because you have to integrate. And we treat these as archetypes. We are not making any claims because we had only 2 cases, that there are probably other alternatives are possibly available. And if you have hierarchical structures, which you can see in these mega projects, they are probably a little bit different. And corporate, we didn't look at the corporate forms and so forth. They're typically probably more closer to the proximal novelty type of approach. Now, there's a lot of questions which we can raise. Are there other modulation approaches? This is a continuum, so probably there are some forms of middle grounds. And there may be also evolution over time. So punctuations, you might possibly punctuate from one form to another. You might start with the sort of this type of digital novelty and build a totally new cool platform. If it becomes popular and gets user base, you probably have to formalize, and you probably may have to start integrating more proximal way. We don't know. It may be that the personal changes in the leadership might influence that too. There's an interesting aspect that what technical or organizational mechanisms or curb the evolution of these approaches. There's also this question how they are initially rooted. There's a lot of work on imprinting in organization theory. And what are the effects of self-selection? What types of participants come to this place? So people who go to this proximal digital novelty and expressionist, they are probably very different types of programmers than those who come and say that we are serious engineers. So there's probably self-selection to the communities, which also sustains certain forms of building the software. There's also interesting aspect how to provide tools of supporting these forms of soft discourse. We didn't analyze that, but they might be using GitHub totally differently, certain features of GitHub. And those enforce, again, certain forms of dialogue. And then finally, interesting aspect is that how does the community discover novelty and negotiate it, and how do they determine what is novel? We didn't really look at that carefully. And similarly, how does it smell complexity? Smell is the word with people in technical depth use it. They smell technical depth. It's very similar idea that they have a certain feeling that the software is getting too complex and they have to do something with it, or that they understand that there's issue of complexity and how do they handle that. That was pretty much it. And thank you. Yeah, Ping, you had a question.
Sorry for another question. Great presentation.
That's fine.
Thank you, Kalle. I found it in the mutual dependence between discourse and artifact really interesting. I have 2-part question. The first part is, could you remind us the vehicles, discourse vehicles that these programmers were using, what kind of channels they use to talk to each other. Second part of the question is, in engaging discourse, did you find that those people more talkative are actually more active in contributing codes, in terms of artifact development, or vice versa? Some more people just engage more talk, but they just talk the talk, but not walk the walk, But actually, some people walk the walk rather than just keep listening and Yeah, the first part is about the discourse vehicle. Second part is about the correspondence of their engagement in the discourse and artifact development. Thank you.
Both are very good questions, and I have some answers, not very good ones to either of them. We didn't examine specifically where the differences in the way in which they talk with one another and through which channels. Because they were both operating in GitHub. There's a certain standard way in GitHub how you actually, because as you know, there's a Git, which is actually the system which manages the code base. That's a software which was built by Linus Torvalds. And then the hub is the sort of social media layering on top of that, which allows you to sort of communicate within each ticket or pull request. I talk with others about how they are going to develop the software. Then there are, of course, additional communication channels, especially from the people who do the code reviews and pull request reviews. They may send separate emails or memos, or they may attach them to as part of the sort of code base when it's done. So these are the main mechanisms which are publicly visible for the community. And then, of course, one thing which we couldn't do is that they always talk with one another through email or through chat, and these you cannot sort of really follow, or the Slack or something like that. And that we couldn't follow. And there's also, especially in the core, people occasionally meet either face to face or through Zoom. But these are sort of all over. Now, with regard to talk and walk, my general understanding, and also spoke based on this study and another study which we are currently doing, is that if you look at open source, walk always matters. It always comes. You don't establish any position unless you deliver. You have to show that you can write code which is acceptable to that community. Otherwise, you may have a talk, but it doesn't count very much. So that's the basic sort of principle. So there's a certain level of how do I put it? If you interpret what I said here, it means that we made already the assumption that all these who made contributions, they had already established a certain standing in the community. They had demonstrated that they can provide something which is useful. And typically the way that these are thrown out is the maintainers. They get all types of proposals, and they just look at them and say that, go back, I don't care about you, pretty much. They can be pretty rude on that, depending on the community. But if they find something which is sort of looks high quality, good enough, then they say that, yeah, we are happy to talk. And much of that, what we looked at was that is second layer.
Okay, thanks. Thank you.
All right. There are two Esade.
Well, thank you very much, Kalle. Really interesting presentation. I have two questions, very short ones. I mean, the first one, it's about engagement and participation and size of the community. These are kind of the big problems that you always have in open source. I mean, how you establish a discussion between large communities and so on. Did the two methods relate in any of these characteristics, like size, engagement, and so on? And then my second question is, do you have any guess of what could happen with communities that are mixed, like Julia, modular, where you have a freemium model, where you have an open source part, but also do you have a company behind that is driving most of the game and so on?
Well,
Thank you again.
These are good questions. With regard to the first one, again, we didn't do that study. That would be a separate study. There's another aspect of that, is that what is the size of the network or the discourse in relation to the novelty, for example. And novelty is typically which dominates. Complexity is an issue which it's a back burner all the time, and people only address to it, that's my experience in many cases, only under the crisis, when it really becomes important. Unless there is a certain discipline process to handle that, and most communities don't have that. That's my understanding. I cannot answer that question. And if you look at our data is from, as you could see, it's near 10 years old. Whether that applies exactly now, the tools have expanded, the environment and the other things have expanded, whether it's exactly the same, I doubt. But I'm also convinced that generally the way in which they sort out what is good and what is not good and how they determine the overall directions is follows very similar principles. I think the principles which we are able to synthesize or pull out for sure applies. I have another student who studies creativity, and he has also studied open source and interviewed people in open source communities. Those interviews confirm very similar view what they currently do and these were very large software communities. Very similar approach. With regard to the role of the corporate governance, I think that if you get corporate governance, they don't like surprises typically, and they want to have a certain, they don't want to dictate, but they want to be sure what is the direction of the community, what is the technological roadmap, and what types of communities and users they want to cater for. So they are, you could say that if I have to make a bet, I would say that the larger this is more like a hypothesis or proposition, the larger the level of corporate involvement, the more likely they are going to follow the tuning approach. Because they sort of make sense. They want to have stability and predictability. All right, Maha.
Thanks, Kalle. Again, really great presentation. I like this paper so much. So I've got two questions. I'm not sure. I mean, they're more, I think they're broader. First one is I'm really intrigued by, you said that this paper, of course, it comes out of Aaron's thesis. It's been a while in the in work, and I know from my own experience that happens with my work too, and many rejections along the way. So I'm curious as to how you ended up looking at novelty and complexity and where it started, because one of the things you said initially was that the data suggested this, but then if the initial data was truly those 25 interviews, then what kind of questions did you ask in order to get to novelty and complexity as key issues, right? Or how broad was the interview guide? And then how did you sort of do the data collection or further data collection and funnel it? And the second question is more about within each case, so whether it's Ruby or Django, weren't there instances which were outliers and which were critical? So I know you've got amazing limitations, you've been very clear there, and also for the future research. So it's very tidy. And of course, a wonderful publication, MISQ, always tends to do that. But I'm more curious as to how rough it looks before we get to this beautiful, sophisticated level, because I'm thinking about what happens in that in the case that was that wanted consensus, because when somebody wouldn't reach consensus, I mean, it's impossible. I'm sorry, I know from personal experience with a lot of open source communities, consensus is not a possibility if the community is large enough. So what do? Push those community members out? And then you raise the other issue, which I think relates to Ping's point, because you're doing at the second level, the maintainers had already filtered certain proposals, in which case then you've got this other device, these maintainers saying what's complexity and what's novelty. So yeah, sorry, I know I got a little confusing there, but these are the two big things that I was kind of curious about.
Very good questions, which is that you want to get into the sausage factory. I sort of showed the sausage, so to speak. With regard to the first question, and that was that what was the sort of evolution? We started with the novelty was always there, and this came very clear from the interviews. Originally, that and the interviews were largely that just let us know how you did the previous release. How did you build it up? How did you come up with what it is? Tell me. I think that there is the interview protocol in the paper. If not, we can find it. But it was generally, we didn't have very focused questions originally, and what we did for certain people, we did actually add more than one interview. But from those interviews, it came clear that novelty was one of the aspects which they had to handle all the time, and which led to this sort of looking at how software communities and generally software developers deal with that. Of course, software development, generally they talk about now innovation and other things, although most of that is not innovation. There's very little innovation actually in software itself. Most of the software development projects don't innovate at all. They just deliver a product for known little less innovative aspects. Open source is in that sense much more interesting because there's this idea that anybody can come with the new ideas and they try to get them through. And they want to evolve that. They are participating because they want to contribute to something which is novel and new or useful and get their own ideas through. So it's not surprised that novelty comes as a sort of important element. The other one, originally we had technical debt because that was another aspect, but the reviewers didn't like it. So we dropped it and we went with this term which we currently use, which is complexity. Of course, complexity is, I think they were right, because complexity is a feature of the software like novelty. Whereas technical debt is a relationship of the organization to certain features of the software and how these relationships is manifested in certain type of economic aspects or risk aspects. And technical debt is largely this type of relationship. So I can understand quite, and that sort of helped to address one aspect. The other one which we added later was this proximal and distal. We had other types of ways of doing it, but this seemed to be working much better at the end. So those were the main changes which we had to do over the time. We had also originally the term epistemic stance, which is another term which we thought that these communities expressed different epistemic stances towards the artifact. So the way in which they know about it and on what grounds they view this knowledge is valid were different. But for whatever reason, the reviewers didn't buy it. So we went to this simpler, more pragmatic notions of doctrine and principles. Which sort of captures the same thing, but in a more it's not that bold, that abstract notion as epistemic stance. So these were the main changes which we did. We had original 4 communities. The 2 were much more mixed in terms of their complexity and other things. These were like the pure cases. So we basically, that's the reason we went to archetype. It helped to write a much cleaner story. So not always a higher number is better. That's what I learned from this one. If you can tell a good story with 2 ones, to pick up 2 instead of picking up 4 and have a much more complicated story. Then you asked about the were there different opinions or different? Yes, for sure. But of course, you have this choice or challenge that you want to provide the sort of clean story, and that's what we provide here, which is the social fact, so to speak, the ideal type. So you should treat these more like ideal types of analysis of these cases, because in any social setting, especially in open source, you will have different voices. And if you look at, as you pointed out, people may have a different opinion about certain things, but most likely they will leave. So there's this type of self-selection. So it becomes more like a self-fulfilling prophecy, a certain form of way. People who have a certain attitude or a certain way that they think about software and what is their own identity and how they can pursue or manifest, enact that identity in that setting, it becomes much more important. In that sense, open source communities are interesting settings to study. They are very different in that regard from traditional software development organizations, where you don't have this. You are there based on the employee relationship, money, basically.
That was great. Thank you. I think Ping has another question. So.
Yeah, this discussion is really exciting. I see a parallel story, even though I don't study open source development very often. But I find that the story, the tension between novelty and complexity is very similar to the tension between creativity and quality, so-called generativity tension in digital platform ecosystems. So in platform ecosystems, you have autonomous players joining, just like open source developers. They're not employed by the by the project or by the platform, but they have mutual dependence. They bring in creativity. If too many parties are involved, then you have huge increasing variances in terms of innovation quality, product quality, whatever innovation you're producing. So I find discourse plays an important role in resolving this tension. And another interesting concept that has been implicit throughout this your presentation, Kalle, is the word scale, because scale is very interesting because by definition, scale is the temporal and spatial metric that you use to study a phenomena. And a lot of the open source software claim they're scalable and their communities are scalable. So on this Diango's website, they said we are exceedingly scalable, right? But scale means they literally they mean they bracket something in and that brackets something out, right? So it's when they mix things, they're including things. When they filter things, they filter things out, right? Something out. So essentially, from an information perspective, a scale is a filter of information. Something gets in, something gets filtered out, something gets filtered in, something gets filtered out. And then when there's a tension happening at certain scale, and it can be resolved at a higher scale, like this guiding principles, is always coming from the higher level, which is a larger scale. And then discourse plays an important role in this scaling strategy, scaling solutions to the tension between novelty and creativity, between novelty and complexity, between creativity and quality. Yeah. So
thank you.
just
we haven't thought about that way.
Yeah.
Had I known that, I would have written the conclusions a little bit different.
Yeah, but that's just an idea that came up to my mind. Thank you.
Yeah, so there's an Esade, another one. I think that probably then we are ready.
Yes, very, very short, just to build on this idea. I think that your paper builds a lot on the term of institutions in open source, this set of norms, this set of governance that the open source and the community builds on itself, and so on, and how these different institutions that you portray, one that is more directed, and another one that is more, they favor different outcomes in terms of novelty and in terms of the shaping of software. And I think that's a pretty interesting idea of how the governance and the institutions around open source shapes the outcome of the community. Just this short comment. Thank you.
Thank you. I agree on that. If you look at but we didn't write it that way because there's probably enough concepts and theorizing and loading with the additional constructs and additional frames, probably would have just confused the reviewers. But lurking behind that, if you look at the cycles, that's a institutionalization cycle. It's guidance basically. And you could think that discourse is certain form of practice. So it is very Giddenscian idea, and it is this idea that you create these stable structures through ongoing action, and ongoing action is the condition to create the structures, not the other way around. But the structures at the same time enable and constrain what you can do next. And you can see here certain logic, which is that there are different ways in which you organize this. Depending on the type of practice which you engage, you build different conditions for handling two structural elements, which is the novelty and the complexity of the software, as it is reflected in the software artifact. Yeah, so that idea was all the time behind it. The whole idea is this type of ongoing cyclical feedback-based activity, which builds over time certain properties, structural properties in this, both the artifacts and also at the sort of level of the community. There are certain cognitive frames. You could say that these are like the modalities of, in Kieran's terms, cognitive modalities and normative modalities.
I think that's the last. Yeah, that was it. And unless there's anybody else who has a burning question, I just want to thank Kalle. That was so cool. A really lovely paper and a wonderful presentation, Kalle. Thank you so much.
Thank you.
Really
Thank you.
appreciate you
I learned
giving us.
also. Thank you.